All right. So we already practiced parallel lines, okay? So if this slope here, where's it at? I think it's on the previous page, sorry. If this slope here is 2/5 x minus 3, or the equation is y equals, let's write it down here because that's not in a good place there. Y equals 2/5 x minus 3. Does the y-intercept matter?
No. Yes, no, maybe so.
No.
No.
I didn't mention anything about the y-intercept, did I?
Then it shouldn't matter.
The only thing I said is they had to have negative reciprocal slopes, right?
Right.
So if the y-intercept doesn't matter, it can be anything. If it's the same thing, then it's going to be the same line. So if I give you the negative reciprocal slope to this would be what? Go ahead.
Negative 5 over 2.
Negative 5 over 2. So the negative reciprocal slope to that would be negative 5 over 2. And I said the y-intercept doesn't matter. So give me an equation of a line that's perpendicular to this line. It would be what?
Y equals -2x.
Okay? A little louder though for me.
Y equals -2 over 5x plus 4.
Say it right the first time. Negative 5 over 2 x plus 4. Okay? Jamie?
Y equals negative 5 over 2x plus 6.
Yeah. I'm just going to jump over here. Okay, I'll jump over here.
Y equals -5 over 2 plus
Okay? Don't forget the x. Okay?
Oh.
y equals -5 over 2x plus 4.
Doesn't matter with the y-intercept, right? Doesn't matter. As long as the slope is in negative reciprocal, it's going to be perpendicular to this. And perpendicular means they do intersect now. But they intersect at 90-degree angles. Okay? Parallel lines never intersect. Perpendicular lines intersect at 90-degree angles. All right. We're not going to worry about the top one. We did that one already. Let's look at the second one. Let's look at this second. It says find the equation for a line perpendicular to the line 2y equals 4x minus 8. Let's change the way that looks. 2y equals 4x minus 8. We're just going to put it all on the same line. Okay? Now, can somebody tell me what the slope of that line is? Devin?
4.
Okay.
2.
2? Why is it not 4, but it's 2?
Because it's 2y. You gotta divide the y to get it to be by itself.
Yeah, it's not in slope-intercept form yet, Devin. So since it's not in slope-intercept form yet, I can't determine what the slope is. It's easy to find when it's in slope-intercept form, but when it's not, I got to do something first. I've got to put this into slope-intercept form. Right now, it's in a form called standard form, where you have numbers in front of it. Okay.
Just like divide the 2.
So we're going to get the y by itself, but when you get the y by itself, you got to divide everything by 2. Okay? If you divide one thing by 2, you got to divide everything by 2. So Tommy, this becomes y equals 2x minus 4. Okay. So can you give me, Tommy, a line that's perpendicular to this line?
Y equals 2x plus 7.
Perpendicular to this line. That would be parallel to this line.
Y. I lost it.
Okay. Do you remember what perpendicular is? What has to take place? The slopes are not the same, they are Different how?
Because of houses.
Different how? How are they different?
Oh, they flip.
Okay, and?
They turn to negative.
Or positive, okay? So what would the new slope be for the line perpendicular to this line?
Plus 4.
The new slope. You just told me it flips upside down and change the sign. Flip it upside down, change the sign.
Oh, 2.
So that's 2 over 1.
So it's negative 1.
Thank you. It's negative 1 over 2. Okay, so a line perpendicular to this would be y equals negative 1/2 x. What was the last part?
Plus 7.
Plus 7. Does it matter what the y-intercept is?
So,
It absolutely does not.
So if it's like a
It could
negative,
even be the same. It could even be negative 4. Then this one, it can be the same. Doesn't matter because they're going 2 different directions, right? They're going to meet at 90-degree angles. So it doesn't matter if they're the same or not. They just have to have negative reciprocal slopes.
if it
Yes.
doesn't matter, do you have to say the y-intercept, or can you just say y equals negative 1/2 x?
Negative 1/2, y equals negative 1/2 x would be a acceptable equation for this because that would be negative, y equals negative 1/2 x plus 0,
Right,
right?
right.
And just leave off the 0. So certainly that would be one of the answers. Okay,
Just to make
any
one
questions on these so far? Okay, so now we've talked about lines that are parallel, lines that are perpendicular. There's one more type of line. Okay, one more type of line that we're going to talk about. And actually 2 more, I should say. We're going to worry about that a little later though. All right, so let's say, for some reason, I want to write the equation of a line, but I want it to go through a point. Okay? So here's an equation of a line. 3x plus y equals 4. And I want it to go through, the new line to go through this point, but be parallel to this point. Okay? So the first thing you have to do is you have to put this equation in slope-intercept form. Okay? So let's rewrite that. We have 3x plus y equals 4. We've got to make this equation y equals. So we're going to move this 3x to the other side. Well, the only way you can move things is by adding them.
Pardon the interruption. With Patrick MacArthur, please come up to the front office. Patrick MacArthur, please come up to the front office. Thank you.
Or subtracting them. Okay? That's the only way you can move something from one side of the equation to the other. Either you're going to add them or you're going to subtract them. Since this is positive, I'm going to subtract this to move it to the other side. And why did I choose this to move and not this to move? Because I want the y equals in the equation. So I'm going to move this 3x to the other side. So when I subtract 3x from both sides, I'm going to have y equals a negative 3x plus 4. Negative 3x plus 4. Okay? Everybody see that? Where we got that from? Okay. Now, Miss Barney? Yes?
What?
You see that okay? Where that came from? Okay. Another way to think about it is if I want to move this to the other side, I can just pick it up and move it. However, each time I pass this equal sign, I have to change its sign. So if it's positive over here and I'm going to put it over there, I got to change its sign. So if it's positive on this side, it's going to be negative on this side. If I move it from this side to this side, if it's negative over here, it's going to be positive over here. If it's positive over here, it's going to be negative over here. So I can just pick it up and move it, but if I do that, I need to make sure when I pass that equal sign, I better change its sign. Because that's what's happening. You're adding it or you're subtracting it, which is causing that sign to reverse. Okay? Or become its opposite. All right. So we're going to use a formula now called
point slope formula.
the point slope formula. Okay, point slope form. Is that going to come in darker? No. All right, so if we use the point slope formula, here it is. This is going to be an important formula for you to have and to use because you're going to use this all week. Okay. That formula is y minus y1 equals m times x minus x1. So y minus y1 equals m times x minus x1. Now this is a pretty easy formula to use because when using this formula, you just need two things. You need the slope that's going to go in here, so you need an m, and you need a point. You're not going to change this y is just y. You're not going to change this x is just x. This x1 and this y1 are the x values of the point that you're using and the y values of the point that you're using. Okay. So the only things you're going to replace are this x1, this m, and this y1. Just going to replace those. So if I'm going to write a line that is parallel to this equation, okay, but goes through the point, so parallel to the equation y equals negative 3x plus 4 and goes through the point to negative 1, I'm going to use this formula. So let's write down that formula again. We have y minus y1 equals m times x minus x1. Okay. And we are writing an equation that's going to be parallel to this first equation right here. But not just parallel, right? Because we found, everybody in here found a line that's parallel to a line. It was pretty easy to do, right? It was really easy to do. All we had to do was keep this slope and change that point, or change that y-intercept. And everybody named it. So we know there are an unlimited number of lines that's going to be parallel to this line. But we don't want those unlimited lines. We want a very specific line. We want just one out of that infinite number of lines that's parallel to this line. And I want the line that's going to go through the point to negative 1. So a very specific line. There are infinite number of lines that are parallel, but I just want that one. Just that one. That's all I want. So what we're going to do is we're going to replace those values. So we have y minus. The y1 value that we're going to replace with is the y value of this point. So we're going to use that negative 1. I have y minus as part of the formula, so I'm going to make sure that that negative 1 goes in parentheses. Okay?
So when that turned into a positive?
It will eventually, yes. Equals, and my slope I'm going to get from this line, original line. Because I know that if I find a line parallel to this line, it's got to have the same slope, right? So it's going to be negative 3. That x stays the same, and then the x value that goes in place of x1 is the x value from that point. Now that's the hardest part of that equation, what we just did. Plugging in the values. I'm going to plug in the x and y from that point. I'm using the slope from this point. That's the hardest part. You say, well, how can that be the hardest part? Well, really, that's it, because the rest is just simplification. All I do is I'm just going to simplify this equation. So let's look at the first one, because Mr. N said a while ago that that 1 just becomes a positive 1, doesn't it? And I said, yeah, it will. So y minus a negative 1 is y plus 1. Anybody know the property we're going to use next for this one to simplify this? What it's called? Deb? Distributed property, right? So we're going to take that negative 3 times the x, which is negative 3x, and that negative 3 times that negative 2, which would be positive 6. So far I didn't do anything. I just simplified that, right? I didn't do anything, just simplified. But now, to be like this, it's got to be y equals, right? It's got to be y equals. So I got to move that 1 to the other side. Remember I said if you just wanted to pick it up, Jamie, you could just pick it up and just change the sign. So if I make that a negative 1 and move it to the other side, you're going to have this. Y equals negative 3x plus 6 minus 1. So we have y equals negative 3x, and 6 minus 1 is just 5. So this would be the line that is parallel to this line. That would be the line that's parallel to this line, but goes through this point. Remember, there's an infinite number, but there's only one line that will be parallel to this line and goes through that point, and that would be the equation. Yes, sir?
So all it did was just add to the y-intercept 1.
It did, but it could have taken away as well. Depends on the point, right? It's a very specific point. So in this case, it just added 1 to the y-intercept, but it could have done different option depending on what the point was. Okay. Questions on that? All right. So if you turn your page, here are the steps in order to do that. Step 1, you've got to put the equation in slope-intercept form, which is what we did. Step 2, you're going to find the slope of the new line, which is what we did. Step 3, we're going to use the x and y coordinates from the given point to help us solve it by putting in that point slope formula. And then step 4, we're just simplifying that new equation. Okay? Once we have those points in there, the rest is just simplification. So if you go on back to step 4 of that particular series, you can see that you have the equation y equals negative 3x plus 5. All right. So for homework today, we're going to try this one. Okay? We're going to start it in class. We're not quite going to get done with it because we have about 5 minutes left. But we're going to start in class. All right. So write down this equation first. The first equation would be this 4x plus 2y equals 6. And we're going to write an equation that is parallel to, perpendicular to that line, but goes through the point negative 2, negative 3. Okay? So what's step 1? Go ahead. What's step 1? Very good. That's exactly step 1. Put the equation in slope-intercept form. Okay? So take a minute. If you're not sure, work with a partner. Put that equation in slope-intercept form. Okay? If you're not sure, just take the equation, put it in slope-intercept form. So work with a partner. If you're not sure, okay? This one, this one, this one, this one, this one, this one. Got it. Okay. Do you have it? Yes, that's it? Okay. We're gonna do perpendicular, but not just yet. Right now, we're just putting the equation in slope-intercept form.
We have to divide two.
Okay, but it's not quite in slope-intercept form, because that's gotta be y, right? All right, so the first thing, if I'm gonna put this in slope-intercept form, I'm gonna move that 4x to the other side. So that's gonna give me 2y equals a negative 4x plus 6. I moved this 4x to the other side. I picked it up, I moved it. I changed the sign when it came across the equal sign. So instead of being positive, it's now negative. We have a negative 4x plus 6. But this isn't in slope-intercept form yet. We have to do something else. Since this is not y equals, we got to get the y equals. So since this is multiplying by 2, I have to divide by 2. So I have to divide everything by 2. Okay? Everything by 2. And if I divide everything by 2, I'm going to have y equals negative 2x plus 3. Plus 3. Okay. All right, that's as far as I'm going to take it with you today. I want you to see if you can do this one at home. Find a line that's perpendicular to this line that goes through this point right here. Yes, ma'am?
That should be possible.
No, 6 divided by 2? 3. But thank you for double checking. All right, so remember, you're doing a line perpendicular. So you're not going to use this same slope. You're going to use the negative reciprocal slope. Okay, negative reciprocal slope. Have a good day. We'll see you tomorrow. We'll pick up where we left off.
Juniors, please check in to your third hour class.